Welcome, geniuses. I'm Genie, your best buddy for A-levels. In this channel, we'll bring you to explore the secret formula behind success.
In this chapter of dynamics, what you're going to learn you're going to learn about Newton's three laws first. And after you have learned Newton's three laws, then we're going to talk about the conservation of momentum. Alright? So let's talk about Newton's three laws. So before we talk about Newton's three laws, we talk about the definition of momentum. So how would you define momentum? Product of the mass and its velocity. So what's the unit for momentum? Kilogram meter per second, right? So is it a vector or a scalar quantity? Vector. Now because it is a vector, right, many people, right, don't understand how to calculate the change in momentum. For example, let's say you have a floor here, and then a ball comes towards the floor, and let's say the mass is m, the speed is v . And let's assume it undergoes a perfectly elastic collision, which we're going to learn perfectly elastic means CAIE is conserved. So that means it will still bounce off with a speed of v . So what will be your change in momentum? By the way, the symbol for momentum is small p . Alright, so what is the change in momentum? So many people will say, oh, coming is mv, going back also mv, so the change is 0, which is wrong. Because it is a vector, so we have to have a direction. So let's say we take downwards as positive. You can set your sign convention. If you set downwards as positive, then you can find your change of momentum by taking either the initial momentum minus final or final minus initial. Because some people, they only know one way, which is final momentum minus initial momentum. Now, can you use initial momentum minus final momentum? You can. Because the word change usually is modulus. Modulus means we don't care whether it's positive or negative at the end. But when we are subtracting to find the change in momentum, then we have to consider direction. Example, let's say I take final momentum. Oh, sorry, use a blue color. So let's say I use final momentum minus initial momentum. So what is a final momentum since I'm taking downwards as positive? So it will be negative mv, right? Because it's moving up. Then I would minus mv because your initial momentum is positive downwards. So I will get negative 2 mv. But if I take the change in momentum as is initial momentum minus final momentum, I will take mv minus negative mv, which also gives me 2 mv. But the only difference is, on the top is negative, but the bottom is positive. So what should you write? When you write change of momentum, you just drop the negative, so you get 2 mv. You understand that? But that's what I'm trying to tell you. When you want to find change of momentum, especially, you have to make sure that your direction is important. That means if you're taking down as positive, then up will be negative. Then if you are taking, that is your final minus initial. But if you take initial minus final, you must also consider direction. Okay, never forget that. So it's never 0 if it's bouncing. Do you understand? Because many people, they'll put the change of momentum as 0. Because going mv, coming back mv. Not true, because you must look at direction. Do you understand? Okay, let's look at the next part. So if we want to find the direction of the change in momentum, what do we do? Now, the direction of change in momentum is actually related to your Newton's second law. If you remember Newton's second law, it says that the rate of change of momentum of a body is directly proportional to the net force acting on it and takes place in the direction of the force. What it basically tells you is the change in momentum must be in the direction of the force exerted on the body. So if the ball initially was moving down, after colliding with the floor it moves up, that means the floor is exerting a force on the ball up or down? Up, right now, because during the collision it must be pushing the ball up, that's why it moves up. So if the force is upwards, therefore the change in momentum must be also upwards. So we will say the change in momentum is 2 mv upwards. Do you understand? So let's talk about Newton's first law now. So for Newton's first law, it says that the body will remain in state of rest or uniform motion in a straight line unless a net external force acts on it to change that state. So what it basically means is this. What is the implication for us during our solving questions? So firstly, if you see an object stationary, at rest means stationary, or uniform motion in a straight line. Now, uniform motion in a straight line is a fancy way of saying constant velocity. That's it. So constant velocity means constant speed, constant direction. If an object is stationary or moving with constant velocity, then it means there is no net force acting. That's all. So every time you see a question that involves a stationary body or a body moving at constant velocity, you can assume the net force is zero on that body. Understand that? Okay? Now what about Newton's second law? What does Newton's second law say? So it says here, the rate of change of momentum of a body is directly proportional to the net external force acting on it and takes place in the direction of the force. Now, basically, there are many things that we can get from this second law. The first thing is we can actually derive the equation of F net equals to ma from here. Alright, so we need to know how to derive the famous equation F net equals to ma from this equation. Now, for example, let's start off with what they say. So the rate of change of momentum means dp dt. Alright, if some people are not familiar with differentiation, then you can also write as delta p over delta t. Doesn't matter lah. So rate of change of momentum lah. Now, that's what it says. Okay, so then what you can do is you can break down the momentum to mv, right now. Then you must tell them for a body of constant mass. Now, why you must tell them body of constant mass? Because in actually Newton's second law, there are two branches from this. What we learn in A levels is for constant mass. So what we can do, we can take out the m. Then it becomes dv dt, right now. So once you have dv dt, then you remember that you can change proportional to equals. But from proportional to equals, you must put a constant in front. So you get k m dv dt. And remember, dv dt is rate of change of velocity, which is also called acceleration. So you get f equals to kma. How do we get rid of k? It's actually by definition of 1 Newton. You see, 1 Newton is defined as the force when acting on a mass of 1 kg will produce an acceleration of 1 meter per second squared. So the definition, if I substitute 1 here, and my mass is 1, my acceleration is 1, what must my k be? That's how you get rid of the k. That's how you get F net equals to ma. So what it tells you is, for body of constant mass, that's how you derive the equation. But there's another branch which we don't learn, which is for a body with constant velocity, but the mass changes. That means there's another branch where you get body of constant velocity, so your F net equals to velocity dm dt, which is usually used for the case like sand dropping on the conveyor belt. So as more sand drops onto the conveyor belt, the mass increases, but the conveyor belt is still moving with the same speed, which we don't learn in our syllabus. Which is why when you derive F equals to ma from Newton's second law, it is important to write this before you can change from here to here, before you can take out the mass. So don't forget that. Okay? Alright. Now, some people ask me, is that the only way of deriving this? Okay, so I'll teach you another way. Now, you can also derive this F equals to ma from the definition of force. So if they ask you to define force in terms of momentum, you can also define force as the rate of change of momentum. So this is acceptable as well. So from this definition, we can also derive straight away. So if they ask you to define force first, which is F is the rate of change of momentum, you straight put delta P over delta T, which means to say you don't have the directly proportional symbol. If there's no directly proportional symbol, then you won't have a problem with K appearing later on. Understand? So why they can define force this way? Because they know K is 1 anyway. So they can also define force this way. But Newton's second law, you must say directly proportional. But when you ask you to state the definition of force in terms of momentum, then you say it's straight away force is the rate of change of momentum. Don't need to put directly proportional. And if they ask you to derive second law, they derive F equals to ma from this, then you can straight away put there mv over delta t, and then you must tell them for constant mass, then only you can take out the mass, and it comes delta v over delta t, and then you get your ma. So you notice there's no problem if the k coming. Also can. Okay, so the two ways to derive the equation. So what are the implications of second law to us? What is the importance? Now, since your formula F net equals to ma comes from this Newton's second law, right? So what is the implication? Number one, it is your net force that causes acceleration. Now in physics, there are many formulas that have force. Like work done is force times distance. Moment is force times perpendicular distance between the pivot and the line of action of force. Power is force times velocity also can. So there are two different types of forces generally. One is exerted force, one is net force. So you need to know whenever the formula has a force there, whether that force is exerted or net. It makes a difference. For acceleration, it is always net force. In fact, for most of the formulas we have, is always exerted force, except for this. It's always net force. So what is the importance of net force? I'll give you an example. Now let's say you have a block of wood on the floor and you apply a force of 10 newtons. At the same time, there's a frictional force of 3 newtons. And let's say the mass here is 2 kg. So what is the acceleration? So remember, when you use F equals to ma, right? Now, whenever you find acceleration, you always need net force. Net force, acceleration, net force are always together. They're inseparable. In fact, there are only two quantities in physics which will always exist in the same direction, which is these two, net force and acceleration. Net force and acceleration must always exist in the same direction. You can never have them in you cannot have them in different directions. But you can have velocity and acceleration opposite directions. You can have displacement and acceleration different directions. Displacement, velocity different directions, but acceleration and net force always same direction. Do you understand? Example, if an object is moving to the right, then the velocity is to the right. But if it is slowing down, then the acceleration is to the left. So it may be in opposite direction. But if your acceleration is to the left, then guaranteed your net force is to the left. It will never be in different directions. Do you understand? So that's the second one I'm telling you about. So anyway, so what is the force that we must use to calculate acceleration? Net force or exerted force? Net force, right? So you should take 10 or 3 or 7? 7. So you must take 7 equals to 2a. So your a is 3.5. So that's what it means. You must always use net force to find acceleration. Never use exerted force. That means you must find out all the forces acting, then find the net force before you can find acceleration. Do you understand? Okay? Now, next one. If you say that F equals to ma is therefore second law, is also inaccurate. You cannot say F net equals to ma is the second law because F equals to ma was only for constant mass. So we don't say it is second law, but we say it comes from second law. Because many people, when I ask them what is second law, F equals to ma. It's not. F equals to ma comes from second law, but it is not the full story of second law. Do you understand? Okay. Next one. From this equation, F equals to delta P over delta T, do you realize that I can bring the delta T over? So I will get change in momentum, delta P, equals to F times delta T, right? So it means that you can also find the change of momentum if you take F times delta T. But you can only use this formula straight away, provided your force is constant. If your force is constant, example, if I draw a F versus T graph, your force is constant, then you can use change of momentum is F times delta T. But if your force is not constant, example, let's say the force versus time was like this, you must find the area under the graph. That's what it means. Okay, now, to get the change in momentum. Understand? Also, from this equation, you can also get another thing. For example, let's say you have a graph of momentum versus time. So, straight line again, but not constant momentum. Because your F is equals to delta P over delta T, it means that the force is equal to the gradient of this graph. Do you understand? Delta P over delta T means this over this, which is the gradient. Understand? So these are all the relationships that you can obtain from Newton's second law. So summary, number 1 is a net force that causes acceleration. Number 2, the net force and acceleration must be same direction. Number 3, F net equals to ma is not the whole second law, it's only part of it. Number 4, if you have a graph of F versus T, the area represents the change of momentum. And number 5, if you have a graph of momentum versus time, the gradient represents force. Understand? So this is a summary of Newton's second law.
That's all for today's video. If you're interested in more genuine sharing by other geniuses, please subscribe to our channel and don't forget to turn on the notification bell, ding dong. Also, if you're struggling with 1 or 2 past year questions and the mark scheme just doesn't seem to help, Genie has got you covered. Feel free to let us know what question it is by filling in the Google form linked in the description below. GenieUs Hub will get genius teachers to fulfill your request for the solution. Genie will see you next time. Bye-bye.